All right, this is the final waste notes. So after this, we will be finishing up some labs and then moving into risk and toxicity. So first, shrinking the waste stream. That's where we're starting today. There's a couple ways to do this. We talked about reduce, reuse, recycle previously. So reduce, you can shrink the waste stream by reducing how much you use. If you look at Coca-Cola bottles over the years, actually, let's go ahead and do that. Over the years came up before over history. That's pretty funny. All right, so if you look at these bottles, what you see is the older bottles are using a lot of glass. This shape, we're using a little bit less glass because we don't have this like shoulder on the bottle. And then here, we're using, plastic, so different material. Let's see if we can just look at the amount of plastic used. And I want all, I don't want to. All right, here we go. Now this is from Coca-Cola, so they're of course gonna, want to make themselves sound good. Coke bottle made with plastic from the sea. All right, so this is made using recovered plastic, so that would be like recycling something that previously was considered unrecyclable. And this is this whole program that they're doing. I've heard a bunch of different talks about it, towards zero waste. I know if you look here, let's look and see if this helps. Yes, except cookies. Everybody has cookies now. All right, so here we have those bottles over the years. And let's see, contour bottle, recyclable bottles. So this is where we started with our PET plastic bottles. So doesn't break, resealable, lightweight, recyclable. But then, so 78 in 2000, so after more of the environmental movement has happened, then they start doing these like different glass bottles because they're going to have that impact resistance, so they're not going to break than the original. They've tried aluminum bottles, and then here we have the green bottles in 2009. This is the one I was thinking of. So it's PET, but it's made with 30% plant material. So it's plant plastic instead of oil plastics. So that's one way we can, kind of reduce our waste stream in some ways. We're reducing how much we're putting in the bottles. All right. Next is recycling. About half, well, reusing, but we can't really talk about how that's going to change the waste stream in a really specific way because reusing is more of a personal choice thing, not a like stream size thing. So you can't really have it happen on like a large scale right now. The only good area where you might be able to get people to do it on the large scale, like reusing, is people who are already purchasing like more expensive milk. There are a couple dairies that have switched back to reusable glass bottles for the milk, and you turn the bottle back into the grocery store when you get a new one. So there's a couple of dairies doing that. There are some breweries that are doing a similar thing with like glass jugs, basically, of beer or wineries with wine. But it's more of these like high-end products. They're not like a everyday kind of thing. Because even the dairies, which most people have milk in their fridge, the dairies that do this tend to be like higher end dairies, ones that are catering to people who want their cows to be free range and grass fed and all this other stuff. All right, so last is recycling. This is the one where we can talk about how it shrinks the waste stream a lot more. About half of all cans are recycled. So lots of cans, which is good because we are running low on aluminum that would be practical to mine. Old tires can be recycled and turned into road surface. Newspapers are recycled and used for insulation, although we're having fewer and fewer newspapers produced because people mostly get their news online. And there is some environmental cost to like getting your news online because data is not free. It costs money to, cool down the computers and the servers and things that are bringing this information to you. So there is this kind of digital component to energy usage that we don't normally think about. So loading that web page is not 100% carbon zero, but it's pretty close. Um, Recycling copper will pay lots of money. This is why it is sometimes stolen. You may hear on the news out of model homes. A lot of times people will go into homes that have not been sold yet and steal the copper pipes. Because recycling it, you can actually sell it to the recycling companies because copper is so valuable for what we use it for. All of these things, when we recycle it, it saves money, it saves raw materials, and it saves landfill space. So it's really like a win-win-win, because we are getting like all of this benefit. Now there are some negatives, so we'll talk about that. But first, I wanted to kind of point out some of these. Auto batteries are almost at 100 because most of the time when you get a new auto battery, you are at a auto shop with the car that needs the battery. And you bring the battery with you from home in another vehicle, and you bring it in so that you know that you're going to get the right battery. This has happened in my car several times because it's getting old. And you can recycle it at the like whatever place it is. You know, I can't think of any auto parts store names for some reason right now, like Discount Auto Parts or whatever the other auto parts stores there are. You can recycle it right there. And auto batteries have a lot of toxins in them, so it's great that this works. There is a small percentage of auto batteries that are not going to be recycled that are going to end up in landfill, but it's a very small percentage. Steel cans, aluminum cans, plastic bottles. These are all things that people will frequently think of to recycle. So those are, we've already kind of talked about that. The one I want to talk about a little bit is the yard trimmings, because we don't often think about things like yard trimmings being recycled. But a lot of times what happens is those yard trimmings. So like if you have, cut grass or leaves, you put them in the brown bags. They can be collected separately by your garbage city staff. Um, and those can then be taken to facilities that can compost them to use that as fertilizer. So a lot of times it is recycled. It's just not in the same way we think of all these other things being recycled. All right, so saves money, saves raw materials, saves the landfill space. Overall reduces energy consumption and air pollution. The problem is, in the US, raw materials, energy, and water are almost always sold below cost. It's subsidized by the government to stimulate the economy. Atlanta, actually, we have pretty high water prices because we're paying much closer to cost than many other cities. Raw materials are also often sold at cost or below cost, and energy as well, because they're not taking into account the cost of the environmental like cleanup and things like that. That part of that cost is being borne by like federal government subsidies. Because of that, recycling is often not economically beneficial. It depends on the material. Sometimes you can get new materials cheaper than you can get recycled materials, especially when it's something like paper products or plastics. Recycling plastic is difficult because of contamination. You have to get all the stuff off the plastic. We are getting better with new plastics and with new technology at making it easier to clean the plastic so that it can be recycled. Recycled water bottles cost about 40 cents per pound because of what we have to do to recycle them, while new water bottles cost about 25 cents per pound because of the subsidies. So when you have that kind of cost difference, it takes a company that wants to have this green image, like Coca-Cola wants to be seen as this like green company. They want to be seen as doing something for the environment. It takes a company to want that in order to pay more for the recycled water bottles, because they are paying more. Like it is costing the company. So this is why a lot of times it will be more expensive to get something that comes in recycled packaging. Closed loop recycling is recycling a product into the same thing, so water bottles into water bottles, or just plastic bottles into plastic bottles. Open loop is where you recycle one product into something different. So this would be like taking plastics and recycling it into plastic water bottles, recycling it into shoes, or tires and recycling them into like road surfaces or into playground surfaces or things like that. All right, so here we have our disposal method. This graph is just showing us like what types of methods we are using in the US, starting in the 1960s, going to 2010. So not current day, but getting pretty far. So landfill increased up until about the 80s, and then it's been pretty steady with some small decreases and increases. Combustion with energy recovery, that is our incinerator we talked about, and you can see that that starts to get more economically viable as energy prices go up. Recovery for recycling, again, started pretty small, but then we have the environmental movement in the 70s and through the 80s, and it starts to get bigger, and it has continued to increase over time as we get better at recycling different things. And then this recovery of composting component of recycling. This is again getting better and better as well because more cities are having programs where you can recycle at the very least your yard waste. There are some areas where you can actually compost like food waste, but that is a difficult thing because in order to compost food waste, you really need to make sure that it's not containing things that shouldn't be composted that might have higher chances of having like bad bacteria that would harm people growing on them. So most of what we recover that's the composting component is going to be yard trash, so leaves, grass clippings, stuff like that. So just to talk about composting in general, composting is the creation of organic matter or humus by decomposition under a controlled condition. So this happens in nature, but composting is doing it under a controlled condition, like in a bucket, to produce the organic rich material that enhances soil structure, it enhances cation exchange capacity. So that's things like calcium ions, magnesium ions, any of those like positive ions. Also increases fertility of that soil. Materials suitable for composting include vegetables and vegetable byproducts, so potato peels, zucchini, stuff like that, animal manure, yard waste, and paper fiber that's not going to be recycled. So this is not this does not include things like animal fats, meats, stuff like that. Typically, those products, you can compost them, but it's a lot more iffy as far as what kinds of bacteria you're going to get that are going to be growing and doing that decomposition. Because of that, it's harder to have people think about separating vegetables that have not been cooked in like butter or bacon grease, as is common in the South, from vegetables that are just like, steamed vegetables or boiled vegetables, or even just like baked vegetables and olive oil would be okay. But vegetables that have been cooked in animal products may not be able to be composted as easily. Commercial composting, and again, this typically is going to be your yard waste, paper fibers possibly, and then animal manure because those are coming from like businesses. And it's about 13 to 15% of the waste stream. I can attest to that. Like, we don't make that much trash, even with having a child who's still in diapers at my house. But when we were raking our leaves, and we have like this one giant oak tree, which is pretty common in Atlanta, which may be why they started the whole recycling program. We have a bunch of different species of oaks here. This tree dropped so many leaves over the course of the fall. Like, we raked our yard 3 times and we got about 60 of those giant paper bags filled with leaves. That's a lot. I would say that's probably like compared to how many trash bags we make all year, like that is a significant percentage of the trash, the waste that comes out of my house. So not everybody does that. Not everybody has like this prolific oak tree that drops a ton of leaves. But Municipalities that do that, like the city of Atlanta, it can account for about 13 to 15% of the waste stream, and then that can be reused, and it can be reused for fertilizers, which is great. And then reduce, reuse, recycle. Talked about that at the beginning. Don't think there's really anything else that I wanted to mention. I did want to mention a little bit with the like reuse. I talked about refillable glass bottles, things like milk or beer and wine. Breweries and wineries are doing some of that. But let's go ahead and talk about like cloth diapers and auto salvage, and just cloth in general. So not just limited to cloth diapers. That's just one example. But a lot of people are moving to cloth products for cleaning instead of paper. So you might have like unpaper towels. We just got some for home, like cloth napkins. We can use those at dinner, and that saves on paper towel because you're not using a paper towel or a napkin or something that might end up in the trash. Cloth diapers, the same theory. So the child wears the diaper, you wash the diaper, and you can save. And diapers are like, and it's no joke how many diapers you would get. Um, Most daycares, though, won't let you use cloth diapers. So there are some like barriers to this. Only certain people are going to be able to do that. It's the same thing with those refillable glass bottles. Most of the things that you can get into those are going to be a very certain kind of consumer, more high end consumers. And it may trickle down. That's usually what happens. But right now it's more high end. With cloth diapers, they're like, I have looked at a lot of daycares, and my kids have gone to a couple different daycares over having two kids, because we've moved several times since my oldest was born, and none of the like daycares would have taken her in cloth diapers. They all required the disposable because it's easier for their staff. And cloth diapers, if there's, a bowel movement in them, they have to be cleaned in a certain way. Like you can't just throw that in a bag. Um, so because of that, like it's only going to be a very certain kind of consumer, a stay at home parent, someone who has enough income from the other parent so that one member of the family can stay home. So it's another one of these more high end things. Now, auto salvage, we get to a more like egalitarian reuse. Auto salvage, if a car is no longer functioning, you can sell it to people who will like take the parts. You're usually not gonna, as the like seller of a car, if you don't want to like break it into parts, you're not gonna get a ton of money out of it. But people who do this and break up the car into like the different component parts and figure out who might want this part that works and this part, they can make some money selling those parts, and those parts get reused. They then don't go in a landfill to rust. So that is a definite like niche kind of market where it's not a lot of people doing it, but it is definitely useful on that waste stream. Recycle, again, it's all up there. Oh, and one thing I don't think I mentioned with reduce is using, if you, instead of just decreasing packaging, use biodegradable packaging or photodegradable packaging. So photodegradable means it breaks down in the sun quickly, which, UV light is pretty much always there, just in different amounts. So that's one way you can reduce packaging as well, is by like using packaging that will break down pretty quickly. All right, hazardous waste. Hazardous waste is anything that is harmful to humans or to ecosystems. Collection sites must be staffed with specially trained personnel. They have to know how to treat that hazardous waste. It must be treated before disposal. And there's a lot of legislation on this. Number one, we'll talk about RCRA, the Resource Conservation and Recovery Act. This is designed to reduce or eliminate hazardous waste. You can call it cradle to grave tracking or the Cradle to Grave Act. RCRA is the act that requires places like when I was at Auburn University. I'll use this one because I used it all the time as my example. I used osmium tetroxide in my uh, electron microscope like stuff. So it's got osmium. Oops, can I write here? Nope. Okay. It's got osmium, OS. So if you want to look it up on the periodic table, It's a pretty heavy element. It is toxic. And osmium, it's toxic. You gotta get rid of it properly. It's bound to 4 oxygens. When it is bound to 4 oxygens, it's pretty dangerous. If you inhale it, it can cause major lung damage. It can basically fix your tissue. So it kills it, but keeps it in that same state, which is why I was using it for the microscope. It will keep the tissue from like breaking down, so you can look at it on the slide and it looks like it did when it was alive. So that osmium tetroxide, you would get it in from your supplier, whatever company you were ordering it from, and you would have to record how much came in to Auburn University. Then, when you were getting rid of it, you would have to record how much was going out. And on the bottles, you would have to record what percent of each bottle was what waste. So, for example, when I used osmium tetroxide, I was looking at coral, the coral animal, like little slices of tissue. So we were fixing them, looking at them to examine like the relationship between the coral animal and then the algae. So I'm doing this. When I use the osmium, I put osmium on the tissue. It's like 25% mixed in alcohol. But then I have to wash that osmium off before I can put it in the electron microscope so that the electrons don't all get stopped by that osmium. So to do that, I use a series of different alcohol washes. So even though I started with something that might be 25% osmium, I'm ending with something that might only be 2% osmium. But you would have to keep track of this as you're doing the experiment in your notebook so that you could go back and do the math. They don't expect a 100% one-to-one relationship between what comes in and what goes out, but it does give you a very good idea of this cradle to grave tracking and make sure that what comes in goes out in the proper way. And then we have the Superfund Act. This is the Comprehensive Environmental Response Compensation and Liability Act, or CERCLA. But it's often just called the Superfund Act because it results in Superfund sites. It's a 1980 U.S. federal act. It imposes taxes on chemical and petroleum industries, funds cleanups, authorizes the federal government to respond directly. You guys can read all of the things that it does. The thing that I wanted to point out is that these places, there are many, many of them. Here we have those purples are hazardous waste sites, the blue is aquifers. But we have so many that we can't afford to clean them all up. Brownfields, these are contaminated industrial or commercial sites that may require cleanup before they can be reused, but they're not yet listed as a Superfund because there just isn't the money to clean them up. When I went on my conference to Jekyll Island over spring break, there are 9 Superfund sites, listed sites in that county, and only 3 have they had the money to do anything about yet, because there are so many from our history of being not very great with environmental stuff. All right, examples of what might become a brownfield are here. And then this is just another image of how they can, or an image of how they can manage some of these kind of landfill brownfield sites that might be like a hazardous landfill site. The one thing I wanted to point out, and the reason we put this in this notes, is the testing well. So this is a little different from the standard landfill because you have that testing well to go into the aquifer and make sure that whatever is in this site is not getting out into the aquifer. All right. So last thing, new ways to think about solid waste. Life cycle analyses. A systems tool that looks at materials used and released throughout the lifetime of a product. This is cradle to grave analysis. So this is basically taking what we do for those hazardous things that might be used in industry or in medical research or whatever, and doing that for other products. Integrated waste management. This is an approach to waste disposal that employs several waste reduction, management, and disposal strategies to reduce the overall impact of MSW. A lot of times integrated waste management is something that a city or a municipality would have someone doing to try to figure out how they as a city can do better, or as a company or whatever. And then containing the hazardous waste more effectively. So again, putting in those test wells and all those things. And this has to be done when they clean up the Superfund sites, which is why it's so costly. All right, that is it for waste.